Okay, hello everyone, my name's Lizette, and this is my video on how to solve problem 6 on the stats and probability review. Okay, so problem 6 tells me a box holds 240 eggs. The probability that an egg is brown is 0.05 or 5%. So for A, I have to find the expected number of brown eggs in the box. And the way I did that was by multiplying the probability of an egg being brown by the total number of eggs, so 240. And from that I got that there are 20 brown eggs. 20 brown eggs. Yeah, so that means that 5% are brown and then 95% are not brown. Yeah. Okay, and then problem 6b, so part B of the problem, tells me to find the probability that there are 15 brown eggs in the box. And so I did that by realizing that I need the binom PDF because it's an exact value, 15. And so with that, I was able to input that into the calculator. And since I have the TI-84, what I had to do was press second bars, and then I had to put alpha A for PDF. And then the way it's inputted into this portion is it goes trials, so 240, because there's 240 eggs. Then probability, so 0.05, because that's the probability of them being brown. And then the x value, which would be 15, because that's like the exact number that I want to be brown. Okay, so then I just press enter, and I get 0.073, and I write that there. Okay, and then for part C of the problem, I have to find the probability that there are at least 10 brown eggs in the box. So that is a combination, so it's not an exact value since it's asking what the probability is that there are at least 10 brown eggs in the box, so 10 or less. And from that, I get that I have to use the binom CDF form, and since it's up to 10, I have to subtract from 1, so I'll be left with the remaining. So from that, I have to put 1 minus binom CDF of 9, because it would be up to 9 with 10 being the remainder. So like the other problem, I do the same. So I press 1 minus second bars, but this time it's alpha B because it's CDF, and again it's trials, so 240 comma percent, or probability, 0.05, and then 9, and then it's 0.764, and that's my answer. And since it is a calculator problem, it's important that we write the conceptual likelihood, so greater than 10 and so on.